Good afternoon. This is Ms. Billerbeck, and we are going to talk about speed. So speed is the distance traveled over time taken. So if speed is unchanged during a period of time, it is called uniform or constant speed. So we also have some very important formulas here. So we have average speed equals the total distance over time, total time. Average speed is also an average rate. So rate times time equals distance, and time equals distance over rate. So these are very important equations to remember. So with our first example, the average speed of a car for the first hour and a half is 64 miles per hour, or mph is miles per hour. Its average speed for the next 2.5 hours is 72 miles per hour. What is the overall average speed? So we would multiply rate times time equals distance, because we need to know the total distance that it took to get to one place, and then the next distance to get to the next place. So when we look at this, the car is traveling like this. Okay, so the first hour and a half to this point here, the car went 64 miles per hour times 1.5 hours. So rate times time is distance. So this is the distance down below. So let's look at, make that distance. Oops, distance. I'm misspelling the word distance there. Distance 1. Okay, the next part of the journey is 72 miles per hour. And we're traveling for 2.5 hours. So I'm going to write 2.5 because that's the same as 2.5 hours. And that's distance 2. So it wants us to find the average, the overall average speed. So we want to find the total distance, which this whole thing is the total distance. And we know the time, total time, is 1.1 1/2 plus 2 1/2 gives us 4 hours. So we know the total time. All right, so let's find the answer. Okay, there we go. There, now you can see it. All right, so first we have to figure out, well, what is 64 times 1.5? And that ends up 20, 32, and then 2 times 4 is 1, or 1 times 4 is 4, 1 times 6 is 6, and we add these up. So we have 0, 6, 9. So that means we've gone not, oh, we have to move the decimal. Okay, so our total distance then for distance 1 is 96 miles. Well, let's use the dry erase calculator to find distance 2. So we have 72 miles per hour, and we went 2.5 hours, which is 2.5. So 5 times 2 is 10, carry 1. 5 times 7 is 35, plus 1 is 36. And we have a 0 here. 2 times 2 is 4. 2 times 7 is 14. We add them together, 0, 10, 8, and 1. And we move the decimal over 1 spot. So distance 2 was 180 miles. Okay, so when we want the total distance, we add them. So we add 0 plus 6 is 6, 9 plus 8 is 17, carry a 1, and 1 plus 1 is 2. So the total distance is 276 miles. Now we know the total time of 4 hours already. So now we can find the overall average rate is the total distance 276 miles over the total time, 4 hours. Now we can reduce this to a unit rate. So let's do that. So let's use the dry erase calculator here. So we have 6 4s and 27. And 9 4s and 36. So our overall average speed, how about if I call it OAR, or OA rate, overall average rate. Nah, let's not do that. We'll just call it overall average rate. Oh, it's such a bear to write, isn't it? So the overall average rate, and this one would be a unit rate, is 69 miles per hour. So that's as fast as they went. All right, let's go on to the next example. So we have towns X and Y, and they're 180 kilometers apart. So let's draw a picture, because a picture tells 1,000 words. So if this is 0, this is 108 kilometers. Okay, so Susan drives at an average speed of 72 miles per hour from X to Y. So she's driving 72 kilometers per hour times some time t, we don't know, and she arrives at 108 kilometers. Now on her return, she's going y to X, so this is X and this is Y. She drives 54 kilometers per hour. There we go. So times some times time 2. All right, so it says find her average speed for the whole trip. So we know the distance, she went 108 miles this direction and 108 miles, or sorry, kilometers this direction and 108 kilometers that direction. So we know the total distance. Okay, we need to find out what this time is. So in this case, the best formula for us to find T1 would be time equals distance over rate or speed. So let's find T1. So T1 is going to be, the distance was 108 kilometers per hour. Oops, sorry, that's just kilometers. And the speed was 72 kilometers per hour. Okay, so the kilometers are going to cancel, and the hours were down here, but they're in the denominator, so we're going to end with hours over here. So we need to divide 108 by 72. So we have 172 and 108. So that's 636. Drop that down. So if we round this to 7, we know that there's 5. 5 times 7 is 35. So let's try 5. 5 times 10 is 10. 2 is 10. Carry 1. 5 times 7 is 35 plus 1 is 36. And we did it. So this is going to be 1.5 hours. Okay, time 2, we're going to take the 108 kilometers, and we would expect this to take a little longer because she's driving slower. So she's driving 54 kilometers per hour, and the kilometers cancel, so we're going to have hours again. So let's see what that's going to be. So we have 108 divided by 54, and that's exactly 2 hours. So our total average speed, so let's say speed av, for average speed for the whole trip, is going to be the total distance, which is going to be 2 times 108 kilometers, because you went this way and then went back, over, and then we add this 1.5 plus 2 hours. So that gives us 216 kilometers and 3.5 hours. So let's find what that is. So we have 216, and we divide by 3.5. So we need to move this decimal over one spot, and 35 goes into 21, maybe 6 times. Let's try it. So 6 times 0 through 5 is 30. Carry a 3. 6 times 3 is 18, so that's 21. Oh, did a good job with that. And then dropping that down 60. Okay, so there's only 135 and 60. So we borrow one here, we have 525. We drop another 0 down, and 35. So did it say find for the whole trip? Okay, so we are going to do our best to round this. So we have 35. Okay, that, we'll round that to 30, so 8 maybe. So let's try 8. No, 8's too much. Let's do 7. So 7 times 5 is 35. And then that's 21 plus 3 is 24. And we subtract and we have 5. So it's going to round to about 61.7 kilometers per hour. Okay, so that was a tough one. So now we're going to be doing some conversions. So we're just changing the units of something. So it's the same something. It's like, oh, this is about 5 inches, or it could be different in centimeters. So 1, 2, 3, 4, 5, 6, 7. It could be about 8 centimeters. Yeah, so you just conversion means it's the same thing. It's just measured with different units. So 8 kilometers per hour, and we're converting it to meters per second. So we have 8 kilometers over hour. Okay, and we're converting to seconds. So first let's do, there's 1,000 meters in 1 kilometer. So that is just a conversion. That's the same thing. 1,000 meters equals 1 kilometer. So that is a 1 right here. Okay, so it's the same thing. Now, how many hours, how many seconds are in an hour? Okay, so we have, well, let's do 60 minutes and then 1 minute over 60 seconds. Okay, so if we did a good job, we should be able to cross off our units like this. And now we're down to meters and seconds. So we have 8,000 on the top, meters, and on the bottom we have 3,600 seconds. So we can cancel those two out, and now we reduce. So what is 80 divided by 36? Well, let's see. Okay, so there's 236 in that, so that's 72. Gives us another 8, and we drop that down. So it just looks like it's 2.2, and it's going to just keep going. So this is going to, oh, and it says to the nearest meter. No, it just says convert to meters per second. So 2.2 bar, because this is going to repeat, meters per second. So that's how you would do the conversions. All right, let's try kilometers. Well, we have kilometers equals 0.62 miles. So that's going to be very important for the next few examples. So, and also for other things. So we are going to convert to the nearest 10 miles per hour. Oh, what are we converting? I think I forgot to write down something. Okay, so it says 80 kilometers per hour. Oh. Okay, so we were going 8 kilometers per hour. So let's convert 8 kilometers per hour and not 80. So So we're converting 8 kilometers per hour. So 2 miles per hour and the nearest 10. Well, let's hope we're going that fast because this is pretty slow. Okay, so we have 8 kilometers over hours. And we want to, this is an hour, so we're just converting the kilometers to miles. So we have 0.62 miles equals 1 kilometer. So we cancel and we multiply 8 times 62. So that gives us 8 times 2 is 16, carry 1. And then 8 times 6 is 49. 48 plus 1 is 49. And we move it over to decimal places. So we have miles per hour. Now, it did say convert to the nearest miles per hour, 10 miles per hour. But this is not 5 or above, 5 or more raise the score. It's 4 or less, let it rest, because it's just under 5. So technically, if we're rounding this, we went 0 miles per hour. Can you believe that? That's what that would round to the nearest 10 miles per hour. It would be 0. Isn't that funny? Okay, well, I made a little mistake there. It was supposed to be 80 kilometers per hour, and I wrote 8. So that's why we had such a funny answer. But it's all the same number crunching. Okay, so we have a pronghorn antelope can run 61 miles per hour. Convert the speed to kilometers per hour. So we have 61 miles per hour. And we know our conversion for miles was 0.62 miles per 1 kilometer. Because these two things were equal. So we can make them as a ratio. So miles cancels, and we're going to have kilometers per hour. So we end up with 61 divided by 0.62, and we have kilometers per hour. But we need to know what 61 divided by 0.62 is. So we use our dry erase calculator. And we move the decimal over 2 spots to right here. So there's no 62s and 61, and there's probably about 9 of them here because we just missed. So 9 times 2 is 18, carry 1. 9 times 6 is 54, plus 1 is 55. Okay, so let's subtract, grab 1 from here. So we have 2, we need to carry 1 from here. So 10 minus 5 is 52, and then that's 0. We drop this down. Okay, so this is a little less than 558, so we're going to try 8 this time. So 8 times 2 is 16, carry 1. 8 times 6 is 48, plus 1 is 49, and we're going to subtract. And we have 4. And that's 2, and then we're going to grab 1, drop it down. So we know that there's about 4 of these in here, but there's a 2 there, so we're going to have to say 3. So there's 4 60s in 240, but not 4 62s. That's what I was thinking. So 3 times 2 is 6. 3 times 6 is 18. Subtract, we just missed. So that's 4, 5, And we drop one more down just to see how to round. And this is a little less than that, so it's going to be about 8. So if we're going to round this it doesn't say what we're rounding it to, but we probably don't want to go beyond the tenths place here. So it's going to be 98.4 kilometers per hour. So that's how fast this pronghorn antelope runs. And that's it for section 6.3. You have a wonderful day.